So we have some other terms need to be defined. Softening point. You know, at the normal temperature, our binder content is having the stage known as solid. When it is provided some heat, change of phase occur. What do we mean by this change of phase occur? It means from solid going to melt. This temperature is known as softening point. Now let me tell you one thing. We have the binder which I explained in my previous video, neat, aged binder and polymer modified binder. How many binder I have? Neat mean original binder, then I have the polymer modified binder, then other binder I have which is gone through the aging. So here I would like to tell you, aged binder has higher softening point. SP means softening point. Similarly, polymer modified binder also has higher softening point. This softening point actually provides us the consistency of the material. So it was just small definition. I thought I will go on telling you such definitions also. Now after this softening point, I have another definition, viscosity. You know, when we are going through the specification or when we are going through the MS2, their viscosity is given that this should be the viscosity for mixing of the binder with the aggregate. This should be the viscosity for compacting. So it means there is the relationship between viscosity and the temperature. So we can say that viscosity, it is an important property at higher temperature. How it's an important property at high temperature? Because pumping of binder from tank to mixing chamber. Okay, whatever the tank we have, where it has gone through the hot stage, where it is being pumped. After pumping, it is going in the mixing chamber. Mixing chamber means mixing with aggregate. To form hot mix asphalt, HMA. Here again same viscosity of modified binder is more than neat binder. Neat or original binder. Second, each binder is more as compared to neat binder. Here I would like to tell you, in my coming videos, although I will explain this because viscosity temperature relationship in detail, but here you keep this thing in mind. You know, if we have this polymer modified binder, we will have to increase the temperature in order to reach to the viscosity, because it's very difficult to reach to that level of the viscosity, because more temperatures are required. Because you know, in normal temperature, I will just give you one example. If we have simple binder grade like 40, 50 or 60, 70, maybe we can say that in order to pump it, in order to mix it with aggregate, temperature required would be between 153 up to 160 Celsius. But over here, for this polymer modified binder, its temperature is always more than 175 Celsius. So whatever the word I have written over here, it is a proof. It is a proof that polymer modified binder, the temperature is always more, because in order to produce the viscosity of the same level is difficult. Thank you for saying this.